Hi class, in this video I want to work one of your harder problems from the homework, question number 13 for week 2. Okay, so the problem begins like this. The amount of time adults spend watching television is closely monitored by firms because it helps determine advertising pricing for commercials. Okay, so let's complete these 4 parts, A through D. Do you think the variable, so if we recorded this on people, the weekly time spent watching television would be normally distributed? If not, what shape would you expect it to have? So weekly time watching television. So if you think about this, I think most of us watch a little bit of TV each night, maybe between 0 and 2-3 hours a night, okay? But are there people who spend all day watching television every day? Absolutely. Are there a lot of them? No. So what that means is most of us are around, probably somewhere between 10, 15, 20 hours of television a week, but then there's some people who are watching 40, 50 hours of television, but not that many. So what that means is the variable weekly time spent watching television is likely skewed right, not normally distributed. So we got that. So according to a certain survey, adults spend 2.25 hours per day watching television on a weekday. So that's an average. They're kind of telling you the average there. So assume the standard deviation for time spent watching television on a weekday is 1.93 hours. So they're giving you the standard deviation. If a random sample of 40 adults is obtained, describe the sampling distribution of X bar. Okay, so the sample mean, the mean amount of time spent watching television on a weekday. Well, the central limit theorem tells us that the distribution of X bar will be approximately normal. This is because the sample size is greater than or equal to 30. With mean use of X bar equal to whatever the population mean is, so 2.25 hours. And the standard error here, like in the previous problems, you're going to take the population standard deviation and divide this by the square root of the sample size, which was the 40 people. So I'm going to hit enter. And I'm going to have to take this, 0.305159. I'm going to have to round it to 6 decimal places. So when I do that, 0.305160 actually when I round it. I got it. All right, determine the probability that a random sample of 40 adults result in a mean time watching television on a weekday between 2 and 3 hours. All right, so I know it's normally distributed, mean, standard error, then they ask you for a probability. I'm going to load up my stat crunch. I'm going to go stat, calculator, normal. I want to be between 2 and 3 hours. So I have to put in the mean here, which was 2.45, I believe. Or 2.25, excuse me. And then I have to put in that standard error I found before. So that 0.305160. I'm going to hit compute. It's a really large probability. So they asked me to round to 4 decimal places. So taking this out to 4 decimal places, I'm just going to have to change that 6 to a 7. And I got it. All right, part D is the hardest part of this problem. Okay, and this is where they really try to trick you. So one consequence of the popularity of the internet is that it's thought to reduce television watching. That's a good thing. Suppose that a random sample of, notice how up here it was 40 individuals, but now it's 35 individuals who consider themselves to be avid internet users, results in a mean time of 1.79 hours watching television on a weekday. All right, so determine the likelihood of obtaining a sample mean of 1.79 hours or less from a population whose mean is presumed to be 2.25 hours. So we know the mean to be 2.25 hours, okay? So they want to be less than, this is what they're asking you, okay? Less than 1.79 hours. So that's going to go here. But if you were to just hit compute right now, this would be the wrong answer. The reason it's the wrong answer is this standard error needs to change. So we're using this standard error from the previous problem. But actually now we're only using 35 individuals. So you have to change it. So you have to take 1.93 divided by the square root of 35 and hit enter. And it's going to be 0.326229 or 0.326230. So 0.326230. Going to hit compute. And going out 4 decimal places, it will be 0.0793 when I round it. So we got it. All right, now this one is hard. Interpret this probability. So what this means is if you were to do this 100 times, we would expect about 8% of the samples to have a mean of 1.79 hours or less. Okay, so that's if you do it 100 times. But now, if 1,000 different random samples of size n is equal to 35 individuals are obtained from populations whose mean is assumed to be 2.25 hours obtained, we would expect a sample mean of 1.79 or less in about. So take this and multiply it by 1,000, that probability you just got, and about 79 of those samples. And there we go. We got it. So based on the results obtained, do you think avid internet users watch less television? So if the likelihood was less than 5%, you would say yes. So since it's above, we're actually going to say no. All right, class, I hope that helped.